All right, so what's the point of the unit circle? The unit circle, the coordinates on the unit circle actually give us the sine and the cosine of the angles that they are matched up with. So if the key phrase, term, whatever you want to call it, to remember sine, cosine, and tangent is SOHCAHTOA. But as far as the unit circle is directly concerned, it really only immediately gives us sine and cosine. Everything else we kind of have to figure out. So we know that the sine of an angle is the opposite over the hypotenuse, and we know that the cosine of an angle is the adjacent over the hypotenuse. So again, the cool thing about the unit circle is that the radius is 1 unit. So as far as the triangles are concerned, the hypotenuse is always going to be 1. So we can rewrite this as the sine of theta, and the opposite side, this is always the opposite side because this is always my angle. The opposite side is always the y coordinate, and the adjacent side is always the x coordinate. So as far as these coordinates are concerned, the cosine of the angle, the cosine of the angle is the x-coordinate, and the sine of the angle is the y-coordinate. So, keeping that in mind, we should be able to take the sine of any angle on the unit circle and immediately be able to determine what the sine and what the cosine of those angles are. For instance, the sine of 3 pi over 4 would be square root of 2 over 2. The cosine of 5 pi over 4 would be negative square root of 2 over 2. The sine of 11 pi over 6 is negative 1/2. The cosine of 5 pi over 3 is positive 1/2. And that's what the unit circle does for you, which is why it's really good to have it memorized. So hopefully you have that accessible somewhere. I went to Desmos, gotta give credit where credit is due. Desmos, I made this nice graph. Now I did add some extra lines on here. The black and the red lines represent positive square root of 3 over 2 and negative square root of 3 over 2. And the blue and the green lines represent positive square root of 2 over 2 and negative square root of 2 over 2. That'll come into use later when we're actually graphing sine and cosine, because that's what we're doing. But first, what we need to really understand is what is a function. A function takes an input and it gives an output. So if we're graphing sine and cosine, let's just talk about one at a time. The sine of some angle, or actually let's write it as a function maybe, that y equals the sine of x. So if we're inputting x, it's going to output the sine of that. So we're going to be inputting angles and outputting the sine of those angles. So if I ask what is the sine of 0, well, what is the y coordinate of 0? And if I look back at the unit circle, the sine of 0 is 0. Cool. So the sine of 0 is 0. I'm going to put a point there. We didn't do pi over 12, then it's pi over 6. What's the sine of pi over 6? So what's the y coordinate of pi over 6? It's 1/2, which is on the graph. The sine of pi over 3 is square root of 2 over 2. So I'm putting a point there. The sine of, pi over, why did I mess that up? The sine of pi over 6 is 1/2. The sine of pi over 4 is square root of 2 over 2. The sine of pi over 3 is square root of 3 over 2. And then we skip 5 pi over 12 and pi over 2. The sine of pi over 2 is 1. Now thinking about the unit circle, also let's talk about decimals real quick if you're doing this on regular graph paper. 1/2 is 0.5. Square root of 2 over 2 is about 0.717, I think. And square root of 3 over 2 is 0.866. Check those, just throw them in a calculator, but I think that's what those are. So keeping in mind the unit circle, we just finished the first quadrant. If we go into the second quadrant, it's just going to be sort of the mirror image of the first quadrant. So the sine of 2 pi over 3 is square root of 3 over 2. The sine of 3 pi over 4 is square root of 2 over 2. The sine of 5 pi over 6 is 1/2. The sine of pi is 0. Then we do the same thing going down. The sine of 7 pi over 6 is negative 1/2. The sine of 5 pi over 4 is negative square root of 2 over 2. The sine of 4 pi over 3 is negative square root of 3 over 2. And the sine of 3 pi over 2 is negative 1. The sine of 5, again, this gets mirrored, so I don't even need to look if I'm graphing it, because I'm going to get that. Now this gives us the nice looking sine curve, just like that. Doesn't look too bad. I hit all the points at least, well, for the most part. A little bit off, but you get the idea. Now for cosine, again, we're inputting angles and we're outputting the cosine of those angles. So if I have y equals the cosine of some angle, the cosine of 0 is 1. The cosine of pi over 6 is square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2. They intersect. That's cool. The sine of pi over 3 is 1/2. And the sine of pi over 2 is, I'm sorry, I'm saying sine. I should be saying cosine. The cosine of pi over 2 is 0. So the cosine of pi over 6 is square root of 3 over 2. The cosine of pi over 4 is square root of 2 over 2. The cosine of pi over 3 is 1/2, and the cosine of pi over 2 is 0. That's quadrant 1. Quadrant 2 is negative, so it's going to do the same thing but down here. So the cosine of 2 pi over 3 is going to be negative 1/2. The cosine of 3 pi over 4 is negative square root of 2 over 2. The cosine of 5 pi over 6 is negative square root of 3 over 2. The cosine of pi is negative 1. This pattern just repeats. So we have this point, they intersect again in quadrant 3. And then in quadrant 4, we have those points. So, let's see if I can do this one as nicely. Cool. So the black curve is the sine function and the red curve is the cosine function, the parent functions. These change, these have a lot of ways to change. They can be dilated, reflected, and translated a whole bunch of different ways, and we'll talk about that later. But those are the parent functions.